Hello viewers, welcome to lesson 4 about matrices. In the previous lesson, we looked at an adjunct of a matrix, inverse of a matrix, and determinant of a matrix. Let me hope you are taking care of yourselves. Please remember to wash your hands, sanitize, keep distance of at least 2 meters from one another, avoid gatherings such that you can keep yourself safe. So today we are going to look at use of matrix in solving simultaneous equations. What are simultaneous equations? These are equations having more than one unknown. But for our case, we shall look at simultaneous equations involving only two unknowns. So we are looking at solving simultaneous equation using adjunct method. We shall basically look at three methods: adjunct, matrix, inverse, and determinant method. So we have an example there where we have two equations: 3x minus y is equal to 7, 2y minus x is equal to 1. Observe carefully in the two equations. We have two variables, x and y, all two unknowns. But each unknown in each equation has got a coefficient. In equation 1, x has coefficient 3 and y has coefficient -1. The figure before the unknown is what we are referring to as a coefficient. In equation 2, y has coefficient 2 and x has coefficient -1. So we form a matrix equation. When we are forming a matrix equation, we create one column of x and another column of y. So in the column of x, we put the coefficient of x. For equation 1, we have a 3. Equation 2, we have a -1. Column of y, equation 1, we have -1, and column equation 2, we have 2. Then we pre-multiply that into xy. You can see if we try to multiply out the equation, the matrices, we shall go back to the original equations. Then we equate to 7, 1. Since we are interested in using adjunct method, we come and find the adjunct of the matrix formed. So the adjunct will be, we interchange elements in the leading diagonal, giving us 2, 3, and signs of the minor diagonal, which is 1, 1. So the signs which have been negative have turned to be positive. Then what you do, you pre-multiply the adjunct on both sides, meaning when you come to the left-hand side, the adjunct must start. Even when you go after the equal signs, the adjunct should start. And by definition, we said in the previous topic, adjunct times a matrix, we get an identity matrix. So if you try to multiply out, we shall come up with an identity matrix 5, 0, 0, 5. Okay? But you will note that identity matrix we get, the element in the leading diagonal 5 is the determinant of the matrix considered. So if you looked at that matrix 3, -1, -1, 2, if we try to get its determinant, we shall have 6 minus a 1, which gives us a 5, which we have in the identity matrix. So our major concern will be multiplying the right hand side, which gives us a 2 times 7 plus a 1 times 1, which gives us a 15. Then a 1 times 7 plus a 3 times 1, which gives us a 10. Okay, therefore 5x will equal to 15. When you divide through by 5, x is equal to 3. 5y will equal to 10. If we divide through by 5, y will equal to 2. That is what we refer to as adjunct method. Welcome to determinant method. In determinant method, we form an equation as we did in the previous method. But to get the original determinant, we get that very matrix. And you're seeing I'm putting straight lines instead of brackets. That one represents magnitude. So when we are determining a determinant, we drop the couple brackets and use straight lines which represent magnitudes. So determinant of the original matrix gives us a 5. Okay, then we shall also come and get determinant x. When we want to get determinant of x, we go to the original matrix, remove that column of x and substitute it with 7, 1, which appear as our solutions on the right hand side. So getting a determinant there will give us 15. Now we're interested in the value of x. Value of x will equal to determinant of x over the original determinant, which is 15 over 5, giving us a 3. The same applies to y. We shall come and get det y. To get det y, we go to the original determinant matrix, remove the column of y and replace it with 7, 1. Then get the determinant, which is 3 times 1 minus negative 1 times 7, giving us a 10. So to get y, we get det y of our original determinant, which is 10 over 5, which is a 2. Then lastly, we look at what we call an inverse method. We start with the same equation, but this time we fight to get the inverse. We shall get the determinant and the adjunct, then inverse. Remember we said 1 over determinant into the adjunct, and we come up with 2 over 5, 1 over 5, 1 over 5, 3 over 5. Do the same, pre-multiply the inverse on both sides. So we shall have the inverse multiplying on the left, and after equal signs also the inverse is pre-multiplying 7, 1. But by definition, an inverse of a matrix times the matrix, we get an identity matrix which is unit. Instead of wasting time to do the multiplication there, just quote that definition and it will lead you to 1001 into xy. Do the multiplication on the other side. We end up having xy equaling to 14 over 5 plus 1 over 5. Then y is equal to 7 over 5 plus 3 over 5. We end up having x is equal to 3 and y is equal to 2. There is an exercise there. Okay, so if it is not clear in the video, go to the e-learning library. Then the link is there, and copy the notes, then do the exercise. But I request you apply all the three methods. Thank you for listening. Don't forget to sanitize all the time. I wish you the best.